Namaste everyone. In this video we will be solving a problem on kinematics. So we have a motorist who is traveling initially at 80 km per hour. So let us say he's at this point, at this particular moment, initial velocity here is 80 km per hour. So at that point he observes a traffic light which is at a distance of 200 meters ahead. So the distance that we have between the point A and point T being the, of course, traffic light. So here let us say we have this traffic light, and this traffic light has turned red, and he also sees there is a clock here, and the clock is showing a time of 10 seconds for him. Clock is showing a countdown of 10 seconds for him. So the motorist, he wishes to pass the light without stopping. So he doesn't want to stop, he doesn't want to apply the brake, he just wants to move with constant deceleration till he arrives at the traffic light exactly when the color changes to green. So when the color changes to green. So that's what he wishes to do. So you need to find out the uniform deceleration with which he has to move in between this distance, and the speed, the final velocity that he needs to have when he is moving, when he exactly reaches the traffic light. So this is a very simple problem, only one case is involved, and so we could use these equations: u equal to u plus at, or s equal to ut plus half at square, or the third one, that is 2as equals v square minus u square. So any one of these equations we could use. So first, of course, we need to find the uniform deceleration. We have the initial velocity, and of course we have the distance as well. So the distance here is 200 meters. The distance here is 200 meters. So we have initial velocity, we have the distance, we have the time. So this equation is most suitable for that. Let's go ahead and use that equation to find the acceleration. So s equals ut plus half at square. So yes is given here for us, that is 200 meters. Initial velocity is 80 km per hour, but we need to convert this into meters per second. So for that we just need to divide it by 3.6. so 80 by 3.6 into time is 10 seconds, plus half of a we don't know, and time again is 10, so 10 square. So we need to find the value of a from this. So here is our calculator. Let's start putting in the values. So we have 200, and this term, when it goes to the other side, it becomes negative, so minus 80 into 10 divided by 3.6. so that gives us the value of this much, and then this value we need to divide it overall. We actually need to multiply this with 2 and divide this with 10 square. Do that, we are getting the value of acceleration to be negative 0.44 meters per second square. So now that we have the acceleration with us, we can easily find the final velocity. And for that we could just go ahead and use this, because now we know the initial value, acceleration, as well as time. So let's go ahead and find this. Initial velocity is 80 by 3.6, and plus acceleration is negative 4.4, and time is 10 seconds. So when you substitute these into our calculator, so 80 by 3.6 and minus 0.44 into 10, that leaves us 17.82. so 17.82, this is the value in meters per second. But since the question gives us the value of velocity in kilometer per hour, let's convert this into kilometer per hour. For that we just need to multiply 3.6. so let's find that in the kilometer per hour. So 17.82 into 3.6, that's giving us 64.15. so 64.15 kilometer per hour. So this is the final velocity. So these are our two results. So this one is for b bit, and this result is for the bit 1, that is a. So thank you for watching this video. Hope you have understood this. In the next video, we will take up another problem. Thank you.